Hey, Sarah, you have a nice car. I know this because I've been in it. Where do you normally park it?
So I do actually park it in the garage. Just
Do you
FYI.
park it in the garage?
I do, yes.
Don't you have two?
We do, and we have a big garage. And actually, this is something that shits me to tears about people in my suburb. They build these big houses and big garages, and then they don't park the cars in them. They just turn them into extra rumpus rooms and all that sort of stuff.
So you're one of these people that puts both cars in the garage every night?
Yes.
Oh, wow. So I'm just got it completely wrong.
You did, but that's fine. I'll play along with it. Although it is an EV, so if the battery ever explodes, I'm toast because I sleep on top, on the level above it.
That's cool.
Not cool. Really hot, actually. Anyway.
Well, you might want to clean out the garage.
Why?
Because we've got a hail warning incoming. Take cover.
My name's Sarah Perkins-Kirkpatrick, and I'm a professor of climate science at the Australian National University in Canberra.
I'm Iain Strachan, a former journalist turned science communicator. We're members of the Australian Research Council Centre of Excellence for the Weather of the 21st Century.
And this is Totally Cooked, the climate and weather podcast.
That'll do.
That'll do.
What do you know about hail, Sarah?
It is big rocks of ice falling from the sky.
Do you know how the rocks get made?
I kind of do, actually, although I'm sure I'll be pulled up for this in a moment. But yeah, I gave a very brief lecture, a very brief number of slides in a lecture recently discussing hail and how it's made by updrafts and rapid cooling. And there's a nod there, but I feel like I'm going to go down a rabbit hole that I won't be able to dig myself out of. So I might just stop there.
Yeah. I mean, you already know more than me, although, you know more than me. I only know that hail is hard stuff that comes from above.
It can really damage your cars and also your body as a person and other infrastructure too.
I sometimes get those texts from my insurance company telling me that there's a hailstorm coming and I don't have a garage or even covered parking. I've just got a space out my window. So I just look out the window and shake my head ruefully.
So apparently, I don't know if it works, but apparently some people put sheets and blankets over their cars just to kind of take the force out. I've never tried it. Thankfully, I've never had anything of value damaged during a hailstorm, but they are pretty common here in Canberra. And there was a really bad one a few years ago that kind of hit right where all the public servants work. And some of them have really expensive cars. And there's still cars driving around Canberra to this day with mass hailstone dents in them from that particular storm.
Tuck your cars in at night, people.
Pretty much.
Okay, so I don't know that much about hail. Sarah knows a little bit more than I do, but we definitely need someone who knows more than anyone. And
we know who knows more about hail than we do?
Who knows more about we know someone who knows more about hail than almost anybody, I think.
I would agree
We
with
are
that.
very excited to be joined by Dr Tim Raupach of the University of New South Wales, who is an associate investigator with 21st Century Weather and an expert in hailstones and in particular the effects of climate change on hailstones. Welcome to the show, Tim.
Yay.
Thank you for having me.
Thank you for sitting through our tortured introduction as well.
Forced humour.
That's great.
I'd like to start with, the same question of sorts that we posed to Sarah, and I'm hoping for a
better
far more
answer.
insightful answer. Well, actually, no, it might be that the basic answer was correct, but I'm sure there's so much more to get into. So why don't we start with...
I kind of stopped myself because, Tim's here with us, so I didn't want to say something. He's like, oh, God, she knows, what sort of climate
I
scientist?
thought you did well.
The question is, what is hail?
So there's an official definition, which is a chunk of ice that falls out of a thunderstorm that's greater than half a centimetre big. Anything smaller than that might be growl, but then once it gets to half a centimetre, that's when the World Meteorological Organization says, yes, that's hail.
Other than the size, is there more to the definition or more to the differences between growl and hail?
So growl is rhymed particles. So it's where you've got a particle, it might be like a snowflake or we call them hail embryos, like a small bit of ice.
Yeah.
And rhyming is where the ice forms on the outside of it. So you can imagine a snowflake which has extra ice deposited on the outside of it. That could be a piece of growl.
Okay.
But then, when it gets to a certain size, it's hail. So after that, half a centimetre.
That word growl, I've never heard before. How are we spelling that?
It's another definition of ice that can come out of thunderstorms. It's GRAUPEL.
Oh, AUPEL, growl. Interesting.
So how many then on that? So, another form of ice that comes, so there's snow graupool, and hail. Is there anything else? Is there like this whole spectrum of ice coming from the sky?
You can get ice particles that would be too small to be, I think, in those categories.
Yeah, right.
Yeah, very, very, very small ice particles. But then, I think once it gets bigger, it falls into those categories.
And is there anything bigger than hail, or is it just all hail from
Mega
1
hail.
centimetre
It's
up?
all hail. And there is a theoretical kind of maximum for how large hail can get, sort of soccer ball size, really, really
Whoa.
giant. But nothing bigger than that can be held up by the forces that work in a storm.
So how does hail get made?
Well, you have a storm, so hail always comes out of a thunderstorm. And one of the main things you have in a thunderstorm is an updraft. So you've got these winds that flow from the ground up into the storm, and they pull moisture up with them. So there's air being pulled up into the storm, and the moisture in that air condenses, it forms clouds, and then it can form these little particles. Some of them freeze into solid ice, and other ones, when it's very high in the storm, get so cold that they form supercooled liquid water. So that's water that's still liquid, it's little droplets, but it's below the freezing level. And that water is really ready to freeze as soon as it comes into contact with something. So when you then have these little pieces of solid ice that are up in this cool region of the storm, and there's all these winds blowing around, it's very chaotic, bits of supercooled liquid water hit the hail embryos and freeze onto the outside of them. And that just happens again and again and again. And slowly the hailstone builds up in size. And then the kind of end of the process is that once it's too large to be supported by the updraft, then it falls out of the storm. And it's important to remember that hail melts as it falls, because the storm is not cold all the way through. It's cold up high, but it's warmer closer to the ground. And as the hail falls through the warmer section, it melts quite a lot, and it can melt away into rain, or if it is large enough, it can reach the surface, and that's when it smashes your car.
So does that mean then, like when you have the hail that actually hits the ground, even if it's like golf ball size or even tennis ball size at times, when it's higher up in the sky being made, it's actually larger because some of it melts away?
It would be at least a little bit larger, but
Wow.
I think it's important to note that small hailstones melt faster than large hailstones.
Yeah, okay.
So the large ones have a lot of thermal mass. So they would have been larger, but probably not by a huge amount.
Yeah,
Whereas
okay.
the smaller ones might really have halved in size, or can even be melted away into rain as they fall. So you can quite easily have hail up very high in the storm, but no hail actually reaching the surface.
Yeah.
I wanted to check my understanding of that process. And it was like there were two things coming together. There was the supercooled water and the hail embryos. Is that correct?
Mm-hmm.
And how are they distinct from each other?
The hail embryo is a solid thing, like it's ice essentially, and usually it's formed around a little piece of dust, something that actually causes the water to freeze onto that embryo, I guess. So that is a solid embryo, and then the supercooled liquid water you can think of like a droplet, but it's just very cold, so it's ready to freeze. So as soon as those droplets collide with the embryo, then they freeze onto the outside, and you can have wet growth or dry growth depending on how fast the water freezes onto the outside.
I was just going to say, what's the difference?
So in wet growth, the water stays liquid for at least a short amount of time on the outside of the particle, and then it can flow into gaps. It can fill any areas that might have space before it freezes solid. In dry growth, it really freezes straight away, and it doesn't flow on the surface of the particle while it is freezing.
But ice is still wet. That kind of breaks my brain a little bit.
When it's melting, yeah. But,
I know. That takes me back to like second year meteorological studies at uni, like learning how rainfall is formed around a particle, etc. Yeah, it's bringing a lot back now.
Mm-hmm.
At risk of preempting, I think section 2 or 3 of this podcast that I've scheduled, how do you know that's what's happening? How do we study that process of hailstone forming? Is it done through experiments? Is it done through modeling, or studying the physics of fluids? Yeah, how did we find that out?
I mean, it's a good question, because there are parts of this that are not really well understood. So an example that's not really well understood is the way that aerosols interact with hail. If you put little aerosols up into the cloud, can you make hail less or more likely? And that is kind of an open question. So there are things that we don't really understand that well. But I think what we do understand comes from a combination of the things you mentioned. So there are lab studies where people might have a wind tunnel, and they actually use high resolution cameras to study particles forming by feeding in supercooled liquid water and that kind of experiment in a lab. Then you could also take instruments up in an airplane and fly them through storms. So there's been a lot of work in America, particularly in the 70s, which made a lot of progress in doing that. They have these crazy stories from pilots flying through hailstorms. And the story I heard was that the pilot just, as he was flying into the hailstorm, he'd lower the seat so that he didn't have the window in front of him. He had like the fuselage of the plane in front in case the hail came through the window.
That wouldn't pass OH&S these days, actually. Yes. Surely that's not safe.
Did they reinforce the glass for those flights?
They did, but still he was nervous enough to lower his seat, but walked away. And then, so that's kind of the experimental side. And then, of course, you can do modelling and you can do experiments using either weather models or physical reasoning that you get out of just sort of physics applied to this.
There was a talk given at our Centre of Excellence just yesterday, this complete coincidence, by someone else who studies the hail, Olivia Rompainen-Marcius from the University of Bern, who had a picture in her talk of, I think it was a Korean Airlines plane, which had been in a hailstorm and was beaten up. It had holes in it. The windows were all smashed and it still managed to land safely. And I was thinking, how the heck did they get that down safely when they couldn't see? I mean, the visibility must have been, just through the broken glass alone, must have been terrible. And yeah, I was scratching my head about that one.
Yeah, well, I think it goes to show why pilots go to such great lengths to avoid anything on the radar that looks like it could have hail in it.
So where in the world does hail fall? Like, are there particular climates or locations that are more prone to hail than others? And what makes them special?
Usually I think about ingredients when we're talking about hail forming. So you need certain ingredients in the atmosphere for hail to be possible. And so I can talk more about ingredients in a minute, but there are certain places in the world where those ingredients come together. They tend to be in the from the edges of the subtropics into the mid-latitudes.
Like, can you give me an example maybe in the Australian context? Like,
so, yeah, sure. Like in Australia, our most hail-prone region is the East Coast, between just north of Brisbane to south of Sydney. And it's in those regions where you have enough moisture availability. You need moisture. It's warm enough for the storms to form, because to have an updraft form, you need air that is warm enough to rise. I guess on the East Coast, you also have sea breeze interactions, which cause lifting of air masses over the mountains, and you get storm triggering there as well. So in Australia, certainly there's this real hotspot between kind of Brisbane and Sydney. And then a few other kind of hotspots in Australia. Canberra gets its share of hail, as you mentioned. There's an area out in the middle of the goldfields near Kalgoorlie, which appears to be hail prone, but has much less data availability for us to study it than other places. So that's in Australia. And then when you look worldwide, there's the Tornado Alley in America, and a hail alley in Canada, in Alberta.
I've never heard of Hail Alley. So
Hail Alley's in Canada. It's in Alberta, and it's just this area where they get more hail than in other places.
So a two-part question. So firstly, is that like a same sort of climate setting as Tornado Alley? And secondly, if the answer is yes, is that because of how like you've got like the northern cool air coming, from Northern America hitting the warmer air that's coming up from the equator, or is it like that's a very generalized?
It has it has mountains nearby that could cause triggering, and does have these plains where you could get heating, sort of surface heating.
Right.
Yeah, I'm not sure about the air movements, but climatologically, you see in Canada, it's known because it causes damages that are known, but it's not on the same level as the Tornado Alley in the States, where really there's a lot of storm activity over the summers.
Okay.
And then elsewhere in the world, you get hail on the sort of the east coasts of the southern continents. So you get hail in Argentina, and you get hail in east of South Africa. We get hail on the east coast, and in Europe, you get hail on the Prealps and around the Mediterranean. Southern France is a real hail hotspot.
Yeah, right.
What's the Prealps, Tim?
The Prealps are the small mountains leading up to the Alps. So over the very high mountains in the Alps, they're too high for hail really to occur. It's too cold essentially. But the Prealps are just low enough for that triggering to happen when you get air lifted off them.
So is that the same process sort of as what happens over Canberra? Because I've heard, being a Canberran for all of 4 years, I've heard that, we're at the foothills of the Australian Alps. And for anyone listening, I'm, doing quotation marks because they're actually not really that high a mountain range. But it can get quite warm here in summer, but we also have the Brindabellas nearby. We have other mountain ranges. So it does sound like it might be like a similar type of mechanism, but without as strong a moisture source as something like Sydney or Brisbane, for example.
Yeah, that's right. Yeah. And I think the surface heating is really important here. This is how you kick off these storms. You really need a lot of energy, which means you need not only moisture but surface heating too.
What about in New Zealand, Tim? Because they've got a pretty big mountain range in the South Island.
So New Zealand does get some hail, say in the north of the South Island, in the Marlborough region. I've heard of hail damaging grapevines in those regions.
Tragic.
But it's not at the same level as, say, on the east coast of Australia.
Do you want a sign on your door that says Hail Alley? That could be your office name.
Perhaps it should be. I haven't thought about that. That's a good suggestion.
Little license plate, like Route 66 style souvenir.
Yes, exactly.
How did you become an expert in hail? What led you down this path? Are you a mixture of hail embryos and super cooled water? What's the story?
I just run around in a cold area and wait for things to freeze onto me.
Pixar, it didn't happen. I want to see this.
I did a PhD in the invariability in rainfall. So I started out talking about microstructure of rainfall, which is essentially like how many raindrops there are and how big they are. And that's important for radar measurements and for modeling. And then I moved from there into looking at modeling of storms and how we could look at storms in models. And from there, I moved into the climate change aspect of how these storms are changing over time. And it all kind of ended up being useful in the end, but it's been a bit of a winding road to get there.
So you weren't like a weird little nerdy 10-year-old obsessed with hail. It's kind of...
No. I always had an interest in storms, but not on a scientific level until later.
Without looking at the script, Sarah, don't look at it.
I'm not looking at it.
Look at me.
Look at me. Look at me.
I want you to... I mean, Tim may know off the top of his head or not, but should we have a guess about what the heaviest officially recorded
I did actually
ever
read
is?
this bit earlier, but I won't look at it right now. Yep.
Yeah, heaviest ever hailstone.
3 kilos.
You've gone over this time.
Oh.
Tim, do you know?
I actually don't know, but I'd guess like 700 grams.
1 kilogram.
Oh, close. Yep. All right, you win, Tim.
That's still pretty wild.
Yeah, that is.
Bangladesh, April 1986.
So when hearing that, hearing, Tim, that it was, the heaviest stone is 1 kilo, what amount of force and updraft and all of those processes that you've just talked about, how extreme do they need to be for such a stone to form?
I mean, I'm not sure I could put numbers on it, but they would need to be really at the very extreme end of possible storms that we get.
Okay.
Updrafts of, I would guess, more than 100 kilometres an hour.
Right, but very, very intense.
Yeah, if I sat down for a while and thought very hard, I could probably, if we could work it out. But, but I don't know.
That's fine. So, but you wouldn't want to be that Korean Air or any plane for that matter flying through a storm like that?
Absolutely not.
That one would probably not result in a happy landing.
No.
How do we predict hail, Tim?
If you're looking at a storm that's coming already, then radar is the best way to do it. So radars work by sending out a signal, some radiation into the atmosphere that bounces off any solid object that's in the atmosphere and then comes back. And so when you see blips on the radar, those are objects in the atmosphere. It might be rain or it might be hail, it might be birds or bats. They are also picked up on radar. So when you get this large blip on the radar and there's storms around, you can see them coming. So you can see where they are, you can see where they're moving, and you have an idea of how big they are. And that's by far the best way of seeing when a storm is actually about to hit you. And that's where the Bureau, for example, gets its information, or partly gets its information to send out storm warnings that you might get an alert for on your phone. If we're talking sort of further ahead, like if you're looking at whether it might hail this weekend, it's a lot trickier. You can look at outputs from weather models, but they give you information on the kind of what I'd call the large-scale environment. So not exactly whether a storm will hit your particular house, but whether the atmosphere is prone to producing storms. And you might be able to say, this weekend on Saturday afternoon, it's looking likely that we'll have enough moisture and enough warmth for storms to be possible. But will a storm hit your house? That's really hard to tell. And it's much easier when it's actually happening. You can see it coming on the radar with a few minutes warning instead of a few days warning.
Well, I've kind of noticed that, right? Like, on the Bureau of Meteorology's app, often in the warmer months of the year, it's like thunderstorms likely,
right.
Thunderstorms possible. Maybe you might get a severe thunderstorm chucked in there.
Yeah.
But it's never like 100% guaranteed ever.
Yeah. And I mean, the problem is that these storms are relatively small things. They might be a couple of kilometres across. And so one that tracks across your suburb might hit your neighbour's house but not yours. Yeah. And it's very difficult to know exactly where they'll go. There's a kind of randomness built in.
Well, that's exactly what happened with the Canberra one in 2020. And even I remember there was a really bad one that hit Sydney in the 90s that ended up with like a huge insurance bill because it hit the eastern suburbs where all the wealthier people live.
Yeah.
But where I live, which wasn't the eastern suburbs, we barely got any rain.
Yep, exactly. So and that event, that was 1999, April. It was only a few days after the anniversary of that event, and it is still the most expensive insured loss event on record if you normalize it to current dollars. So if that event happened again today, it would be the most expensive event.
Yeah, interesting.
Not just hail event, but any weather related.
Any insured loss. Yeah.
And that's because of where it hit. If that hit Western Sydney, it wouldn't have been as it would have it was a dangerous storm. So there would have been damage.
Absolutely.
People live in, their multi-million-dollar houses and drive really expensive cars in that part of Sydney, as well as having a lot of insurance because they can afford to do so.
Right. Yeah. And I mean, as always, the loss is the intersection of the vulnerability and the exposure as well.
Exactly. So,
it all plays into the event.
But people are still talking about that storm.
Yeah.
Was it 26 years ago? Jesus.
In the rest of Australia or around the world, what do you think the most costly natural, I was going to say natural disaster. It's not a disaster, but, what's the most costly weather-related damage that has ever been suffered in Australia? People would probably say bushfires or floods, right?
They probably would. I mean, I think there's an important distinction here to be made between insured loss and real loss.
Absolutely.
Because people whose homes are not insured can still lose their homes, and that is not included in the insured loss amount. And I think, I would never argue that a hailstorm causes as much damage to society as a giant bushfire or a flood, but for sure they're very expensive events.
Yeah, I guess it also depends on the size. Like you can have bushfires that cover, Black Summer in 2019, 2020 covered a whole lot of the east coast of New South Wales. So, the exposure there is much higher, but hailstorms can be more intense and happen so quickly that you can't necessarily get out of the way of them as well.
Yeah. Exactly.
Tim, who's responsible for forecasting hail and how good are they at it?
In Australia, the Bureau is the people who do the forecasting, and so that's the Bureau of Meteorology. They, I think, do a really good job of keeping up with where there are threats across the country. I know that it's difficult work to put out these warnings with enough time that people are able to kind of react before a storm is on top of them, and I think they do a great job.
I think they cop a lot of flack, I reckon, because, you get the warnings sometimes on the app or online or wherever, even on the radio, and it's like, a dangerous thunderstorm is coming or a very severe one or whatever, is going on with that storm. And a lot of the time it doesn't happen, right? Or it doesn't hit your local area. It might have happened 10 kilometres away from you, but not your local area. And, a lot of people get upset like, oh, they got it wrong again. And I think that's, it is really unfair on the Bureau because they're so hard to forecast. And if they don't put out that warning, even if it's only a slight chance of that event occurring, but it does occur, a lot of people could be really, really badly harmed. So I think I agree. They do an amazing job. But yeah, they really do get the raw end of the stick when forecasting. I
mean, I think it's a really tricky thing because you only have to be right once for it to be worth it.
Yeah, exactly. Hard agree.
And it's not an exact science. So yeah, these are really hard events to predict, especially the further out you are. And even while you're watching a storm on radar, they are not totally easy to predict where they're going to go either. So yeah, I think the Bureau does a great job.
I remember like a thunderstorm occurring when I was working at UNSW, or the University of New South Wales, which is where Tim works now, and looking out the window, probably one of the windows that are behind you now, and seeing this thunderstorm roll through that part of Sydney, and then almost every single people in the centre had the weather radar open. It was almost like the storm wasn't happening unless we could all track it on the radar. It was very nerdy.
Yep. I mean, that's the first thing I do when I think there's a storm around as well.
Yeah, me too. It's quintessentially climate weather nerds.
Yeah.
Iain, Zach, do you do that or is it just us?
You know what I've got into looking at recently is the lightning flashes. You can look on Windy, for example, that'll show you the live lightning flashes, and so you can see where lightning's happening, and that's also a good indicator of where the storm is the most intense. So
I never knew
that's
this.
quite useful.
Oh, something else to waste my time or procrastinate with when there's a thunderstorm.
You're like, oh, I'm so busy. I've got so much teaching on. Oh, I'm sorry, I'm late. You're just like on the radars or looking at the Windy app or looking at
Pull
lightning.
over, and look at all the lightnings. Yeah. No comment.
At the risk of segues, I think I might have mentioned this before on the podcast, but Tim, you were at the joint annual workshop that our centre and Climate Extremes went to in November. And during a panel interview or panel session, Neroli Abram was speaking, and people like in small groups and then larger groups started getting up and running outside.
Right.
And it reminded me of the end of Cruel Intentions when Sarah Michelle Gellar's giving a eulogy for Ryan Philippe's character. But Reese Witherspoon has been giving out his diary and like causing a scandal, and everyone starts walking out of the eulogy. And she's like, where are you people going? Don't you have any respect? And that's what I was thinking. But it was because it was raining so heavily that everyone was rushing out to look at the rain. Were you one of the people who rushed outside?
I was not, but I really wanted to.
Me too.
I stayed, but I really wanted to because we could hear the storm. It was windy and there was a lot of rain, and I was thinking there's got to be hail in this, and it turned out later there was. It was just further down the road from where we were.
So did I. I was so like, oh, this is really cool. This is what I live for.
We did open the curtains just to keep everyone in the room.
So other than like being hurt, what's the biggest challenge or challenges in studying and understanding hail?
is really difficult to get data on. Okay. And it's really difficult to model. That is a really big challenge.
Why is it difficult to get data?
So it's difficult to get data because it's relatively rare, and the hailstorms themselves are pretty small, relatively speaking. And so what you'd normally do, if you wanted to collect rain data like I did during my PhD, we'd go and put out an instrument and we'd wait for it to rain over the instrument, and it would. And then we would go and get the data and analyze it. If you do that with hail, it's very likely that your hail instrument will sit out in the beautiful sunshine and maybe some rain, but actually not get hail onto it. Because hail just doesn't occur that often. And when you're talking, so in my line of work, I'm trying to look at how hailstorms are affected by climate change. We need a long time series, like long records, to be able to look at how things are changing. And so that's a really big challenge because we just don't have the data over that kind of length of time when we're talking about observed hail. And the same problems mean that it's difficult to model. And that's essentially because of its small scale. So as you know, Sarah, when you want to model something at high resolution, it costs a lot computationally. Yeah. And so, you need to put a lot of compute power into modeling these storms, and so it's difficult.
For the listener at home, we have climate models that we use to understand what's going on in the climate system. We can do that to understand past events or what might even be happening now, but we also use climate models to look at future climate and to understand how the climate's changing. But we can only run them at certain resolutions. And sometimes that resolution is really coarse and is like a really big area. And for something that occurs on a small scale, like a storm and like hail, the models can't always get it because they can't, they can't estimate that storm properly over a large region. So in order to do that properly, we need to go down to higher resolutions, but that costs more time and money when we're running these things on simulations, on big computers.
Big fat computers.
Big fat computers, they are indeed.
Mm-hmm. Thanks, Sarah.
When I was doing my PhD, Tim, and I remember having a discussion with my PhD supervisor about things that we can't do in climate science and will likely never be able to do. And one of them was actually hail. And this is going back, 15, 16, 17 years. Like, I'm in awe that we've actually been able to make those developments so quickly in the climate. Like, sure, yes, there's still issues, there's still deficiencies that we can't do that you've just mentioned. But the fact that you can actually ask these questions now and do the research on it, like that's incredible that that's changed in less than 2 decades.
Yeah, it is. And now, like, we're on the cusp, I think, of having regularly dealing with kilometre scale global models. So that's global models that have information every kilometre across the whole Earth. Yeah.
And they can do storms, right? They can.
And then you've got the resolution you need to be able to see these storms, because often what we're dealing with is models that say 100 kilometre resolution, and most storms are a few kilometres across. They get lost. You don't see them. But I think, we're on the cusp of kilometre scale modelling, partly driven by AI and other ML, machine learning, this kind of thing. And it is incredible that we're able to do this now.
Yeah, it's amazing.
Tim, you mentioned that data is hard to come by because hailstorms are infrequent. And I'm wondering, are there hailstorm chasers, like tornado chasers in the US, thinking
There
of
are.
the movie Twister? And if so, are they called stoners?
I saw this one
fantastic.
Thank you.
There
Thank
are. There certainly are people who go out chasing storms.
Are you one of them?
Specifically.
I'm not one of them. Yeah, I have
Tim,
never
the
gone storm
stoner
chasing.
Raupach. It's not good for your career.
But
is
do they chase hailstorms? Or is that too hard to predict to be worth doing?
I think most of the people who go out storm chasing would just want to look to try to get close to a big storm, and if it produced hail, that would probably be a bonus for them.
There are definitely storm chasers out there, for sure, like in Australia.
Absolutely.
I was just wondering, if there are people who go out there to gather hailstorm data, but as you probably already mentioned, they'd be out there a while.
Yeah, well, I mean, there are, and also overseas there are some groups doing some really interesting work on trying to go to where the storm is occurring, watching radar and going out and being in front of it and then collecting information. So there's two I can think of. One is it's called the Northern Hail Project, which is in Canada, and they, in this hail alley in Canada, are going out and collecting kilograms and kilograms, bags and bags of hailstones and collecting all sorts of data by actively going out and chasing these storms. They've got a whole team that does that. And another one is in Switzerland, where they want to take drone photos of the hailstones to try to understand the size and the shape of the hailstones. So what they do is they look at the radar and they see where a storm is coming, and they find a football field with nice short grass, so you can imagine one of those kind of artificial grasses in the path of the storm, and they'll go and set up there, wait for the storm to come past, and then take a drone footage of the ground afterwards with all the stones sitting on it.
That's really cool. That's actually a really creative way to assess what's going on. I like that.
Yeah, and that drone method was pioneered by Joshua Soderholm from our Bureau of Meteorology.
Yes. Right. When you originally said drones, I was thinking, oh my God, how many drones do they lose in a storm when they're kind of putting them up and they're getting...
That's after the storm has gone past.
Yeah, that makes more sense.
Yeah.
Segue, a natural segue from that use of very modern technology, and I might be asking you to repeat yourself here a little bit because you've just talked about it, but can you tell us more about the role of machine learning and artificial intelligence in studying hail?
So maybe there are two aspects to talk about. One is around forecasting, and I think we're at a point now where machine learning models are often able to forecast weather that's coming up with just as much skill as traditional models that don't use machine learning. And that is a really interesting, exciting, and possibly kind of scary kind of reality to be facing. And then on the other hand, looking at, I don't work with forecast models, but one thing I have been doing with a research assistant is looking at how we can understand the links between the large scale environment, so how the atmosphere is on a sort of few kilometre scale, and how likely it is for hail to form. And there are machine learning methods that we can use to try to understand which variables and which measurements we can look at to more accurately predict whether any atmosphere might produce hail.
Like, does it often happen that everything's like ready to go, everything's lining up, all the hail ducks in a row, almost ready to be hit down by hail, but then it just doesn't happen? And
more often than not.
Right. Okay.
Yeah.
So what do you need, like, when everything's just like ready to fall? Like what makes it happen, and then why doesn't that happen?
You can have so we talk about atmospheric instability, and that's where the air near the surface is really warm and it's cold up high. And then if you can imagine that if a small kind of bubble of that warm air gets into the cold air, then it rises like a hot air balloon because it's more buoyant. And then it's all on. Then you get an updraft and the storm forms.
Oh, so is it just like you just need like one? I'm just thinking like one hot air balloon, the poor thing like rising up, or do you need many at the same time?
You need something to start it off, because you can have the atmosphere sitting there extremely unstable, but without a trigger.
Yeah,
and
okay.
Then nothing happens. Then your afternoon goes past and you don't get a storm.
So that trigger could be something so small, and it's like the butterfly flapping its wings.
Exactly.
And
and then there's a lot of randomness that is involved. But the trigger could also be like a sea breeze pushing air up the Blue Mountains.
Okay.
Next to Sydney, or it could be a front that comes across. Anything that physically, mechanically lifts air.
I see.
Is going to be is going to be a trigger. But yeah, it's one of the great problems we have in understanding the links between these large-scale environments and hail actually forming is that more often than not, a very hail-prone atmosphere does not produce hail.
Well, yeah, like, and again, this is purely anecdotal, and there's a lot of times you think, oh God, like you can just feel the air that you feel like a hail storm is on its way or a storm is on its way, but it just doesn't happen. That happens a lot during an Australian summer.
Yeah, and this leads into why the frustrations we all have with the weather forecast when it says this weekend might be storm prone and nothing happens. Well, it was storm prone.
Yeah, exactly.
But maybe nothing triggered.
But no one put their little hot air balloon up.
Right, exactly.
Who's volunteering? My
favorite kind of thunderstorm is definitely an alpine thunderstorm, like particularly thinking of Europe, or I have a really vivid memory of being in the Black Forest, which is in probably the Prealps, I would think. I've never heard that term before today.
It is a hail-prone area, the Black Forest.
Yeah, I remember being there with my family on holiday in the late 90s, and probably every night it felt like there was a really big thunderstorm.
Yeah.
Very fast downpour, and then that's it. And it clears, and it's fresh and damp and very satisfying to watch.
Yeah, that has a kind of cleaning effect, doesn't it? And then the air's all crisp afterwards.
Unless you have a really expensive car.
Yes.
I guess no one there.
I think when I was there, it was just thunder and lightning and rain. There wasn't hail.
Okay, yeah.
But yeah.
Once that humidity is dealt with the storm, it is, it's much more refreshing.
And then lots of pine in the Schwarzwald as well. So pine smells great when it's wet.
Yeah.
So does eucalyptus as well, though. We've got good post-rain smells here.
Okay, I'm just going to go on a random tangent now.
Here we go.
Yeah. Strap yourselves in. Who likes the smell of grass after it rains? Yes, Zach's just like right in there. I can't stand it.
Really?
I just don't see what everyone's on about. Sorry, that conversation of eucalypts and pine.
Is it the grass specifically though? Or I think of the smell of rain as not being grassy. I think of it as being kind of something else.
I'm with Tim. Like I feel like I can smell eucalyptus when it's been raining.
Which I don't mind. Yep.
I don't notice grass being wet. That's probably because I'm British and our grass is always wet.
True. I can notice it in our backyard at home when it's after it's rained. Like Zach's right in. He said, on my deathbed, fill my room with that.
Wow.
Is that happening anytime soon?
Yes. Challenge accepted.
I like grass when it's been cut. That's a nice smell.
Yeah. Or maybe I'm getting the two mixed up. I also don't like that smell. Maybe in part because I'm allergic to most grasses.
That's why you don't do any field work.
Yes. Thank you for making that connection that I never made.
Tim, when does hail do the most damage and why?
So it's all about how large the hailstones are, whether there is wind happening at the same time, and then what it hits. So pretty obviously the size of the hailstone matters because the larger it is, the more damage it's going to do. That one makes a lot of sense. The wind is maybe not quite so obvious. That's because if there's a lot of wind blowing sideways, the hail gets blown sideways into other objects. And so windows that are vertical might normally escape, but if there's wind, they might get smashed. And in crops, for example, in wheat fields, they get much, much more damage if there's wind at the same time as the hail forming. It's a real sort of multiplier. And then it comes down to the amount of damage comes down to what it hits. So that's the vulnerability and exposure. A house that's got certain roof tiles that are really strong will be fine, whereas another house that has weak tiles or perhaps has cladding, the kind of plastic cladding on the outside of houses is particularly hail prone.
Okay, for anyone listening purely to the audio, Sarah's making concerned faces in my screen. Have you got weak tiles and plastic cladding in your house,
I'm trying to
Sarah?
think. So when we built our house, our lovely house, because we got tiles on most of the roof. And we know because it was cheaper, and we just thought, yeah, that's fine. We don't really care. Then we've noticed a lot of people in our suburb have put on corrugated iron. What is it called? Colorbond. Like they put on the metal Colorbond roofs.
Aussie classic.
And I'm wondering why, given that Canberra can be quite hail prone, I'm wondering if that's why, so they don't get broken tiles. And yeah, the metal holds up better. And our second story is not brick, it's some weatherboard. So yeah, we're screwed basically.
I think, weatherboard's probably okay, but it depends on there are engineering firms in the US, for example, who do tests on various roof tiles and work out which are the most strong.
Oh well, I guess time will tell.
Weatherboard refers to people who've stopped listening to the episode.
Yes, I like that.
Zach in the corner tuning out. He's
Yes, a
weatherboard.
few times. Sometimes when you look up at Zach, it looks like he's fallen asleep.
Because people might be weatherboard, I want to liven it up with a dumb question. Can hail kill people, Tim?
Yes, it can. It's rare, but it can.
Cool.
Well, but so what is it because it was so big? Because that's another thought I actually had. I've seen photos sometimes with the hail being like really spiky. So that I've got so many questions. What causes that over like, I don't know, a smooth hailstone, and how much more dangerous is it?
I think I know the answer to the first question, but maybe not the second. So
okay.
What causes it is that hail tumbles as it falls. So it's rotating.
Yep.
And the water gets spun to the outside of the object. And then you can imagine this is when you've got wet growth. So the water is liquid for a little bit before it freezes. So you've got this layer of liquid water on this tumbling hailstone. It gets spun to the outside, and then it forms like stalagmites or stalactites. Like it'll freeze, and then because that bit is slightly further out than the rest of the stone, more water gets pushed to the outside by the spinning, and it grows. So you get these big kind of spikes, particularly on large hail. These lobes that come out.
Is that what they're called? A lobe?
A lobe, yep.
Stabby spikes. But
it sounds a bit too medical for my liking.
It does. It's like your earlobes and your...
Yeah, exactly. As for whether it's more dangerous, I'd be guessing. But if I was to choose whether I was hit by a smooth hailstone or one with spikes, I'd choose the smooth one.
Yeah, me too. It makes more sense, right? That something that's spiky will hurt more.
Yeah.
Especially if it's falling out of the sky at 100 kilometers an hour.
How heavy is a cricket ball? I'm trying to think of, comparison point here. Like, you wouldn't want a cricket ball coming at you at 100 kilometers an hour, would you? Unless you're a batsman.
Well, even then, a lot of them try and move out of the way.
Yeah.
Cricket ball size hail, right? I know it would be exceedingly rare, but it has happened.
Yep, it happens in Australia. The largest in Australia was 16 centimetres. Yeah.
Jack's just jumped in the chat and said that a new cricket ball typically weighs between 156 and 163 grams.
So it's still it's not actually that heavy, but it's hard. It's a hard surface. Like it's not like you can have like something that's the same weight but really soft and squidgy, and that won't hurt. And ice is hard. It's very, very hard. So that would hurt.
Don't get hit by hail then.
Yeah, no, better to be inside.
There was a storm, many storms. I can't remember what it was. I don't think it was the Canberra storm of 2020, but it was somewhere else in Australia. And I remember seeing this horrendous photo of this poor mother who had hail damage all down her back, all these bruises.
I remember this too.
And what had happened was they'd hit a hailstorm. It was somewhere in Australia. Her kid was in the back seat crying so hard because they'd been hit by these hailstorms. So she pulled over and went and laid herself over her child to protect the child, and consequently she was right in the path. And it went through the car. Like they were driving, so it went through the car, through the windows. It was it was such a horrendous image to see.
Yeah,
and what they would have gone through. But I can't remember what storm it was
amazing.
now. Sorry, Zach's just sent a link. I'm just going to have a look at it. How
I
do you
have to
find this
say-
stuff so quickly, Zach? We just say it, and are you AI?
There's a pattern developing here, which is that I supply Simpsons references and Sarah supplies the heart-rendering images of families torn apart by extreme weather.
I do
Well,
really.
in this case, they weren't torn apart, luckily.
Families united by extreme weather.
That's right.
We have talked about that very damaging Sydney hailstorm. Are there any other very serious hail damage events either in Australia or around the world that come to mind for you, Tim, or that you guys talk about in the hail world often?
Yep. So, 2020 happened to be a particularly nasty year in Australia. So there were 3 big events that year. There was the Canberra hailstorm that Sarah was talking about before. And I have the numbers here so I can tell you about it. So that one caused $1.68 billion worth of insured losses. That was across not only Canberra, but Melbourne and Sydney as well. There were a series of storms over 2 days that hit those 3 cities. But then the same year, there was 14 centimetre hail in Brisbane that caused more than $1 billion of losses. And then there was another storm in Rockhampton the same year with 12 centimetre hail and $500 million worth of losses. So when you look down the list of catastrophes as they are defined in the insurance industry, meaning high loss events, then quite a number of the big ones are hailstorms.
Did they ceremonially rename Rockhampton Hailhampton for the week?
No.
No.
Ice Rockhampton. Yeah.
Still very
Ice
much
Rockhampton.
Rockhampton.
Yeah, nice. That's good. This is a weather and climate podcast, and I would like to talk about climate change and hail. Can you tell us a little bit about how climate change or a changing climate, a warming climate, will influence the future of hail?
I'll talk again about the ingredients that have to go into a hailstorm, because that's the way I think about the changes that happen with climate change. So to get a hailstorm, you need instability in the atmosphere, which I explained before. It's made more severe if you have wind shear, which means the wind is going in different directions, low down and high up. That if you've got wind shear, then the storm can be more severe, and you need moisture availability. And then there's this other factor of how much melting happens while the stones are falling. So you take the current climate and then you take a warmer climate, and what are the changes we would expect? In a warmer climate, the atmosphere can hold more water. And when it can hold more water, then there's more energy to be released. And as the air is being pushed up in a storm and the water condenses, energy is released and heat is released. And that allows those air parcels to become even more buoyant. They move faster. So if there's more moisture, you'd expect more instability, more storms, and a stronger updraft, which could make larger hailstones. On the other hand, there might be reductions in wind shear, which might work to make the storms less severe. And then a third factor, also offsetting the first one, is that in a warmer atmosphere, there'll be more melting. So small hailstones might just disappear entirely because it's just warmer. They just get melted away. So if you put all that together and you kind of stand from 100 meters back and you say, what do we expect with climate change? The kind of really broad overarching effects would be less often you would get hail. So a reduction in frequency, and that's primarily because of the melting. So even if more hail is formed up in the atmosphere, less of it reaches the surface. But when hail does get to the surface, it's the monster hailstones that don't melt, and you get an increase in frequency, in severity. So less often, more severe. That's like the very broad overview.
Which matches the broad predictions of precipitation in general, right?
Yeah, I mean, there's still a lot of uncertainty that I should sort of flag when it comes to hail, because although that's our kind of view from a distance, when you actually look at the records that we do have and the modelling that we do have, there's a lot of variability depending on where you are in the world. And so there's a lot of juggling of those balances between those offsetting effects. Which one wins out determines which way the effect goes. And so, for example, I'm seeing in my work that in Brisbane, there seems to be more uncertainty there because the effects are more kind of balanced. Whereas in Sydney, we're seeing a big increase in instability, which is kind of pushing up the severity and the frequency also.
I actually have another question that is not on the sheet.
Ask it naturally.
Is there a universal hail measurement scale? Because I've just been reflecting what we've said today so far, and we're talking about sports balls. Is there like a universal system to measure hailstones?
Sort of, but not really. In Australia, we call anything above 5 centimeters giant hail.
Ooh,
but in America, giant hail is 10 centimeters.
Yeah,
so,
right.
You know, there's a little bit of a mismatch.
Just a smidge.
In agreement.
Everything's bigger in the US. It's like portions in a restaurant.
There are terms that get thrown around. The ones that get used most often in kind of the science side of things would be like giant hail or even gargantuan hail, which is another one invented by US researchers to talk about very, very large hail.
Yeah,
I can't remember the threshold.
Maybe we should stick to how the Australians do it and just always refer back to some sort of sporting
I think it's more safe.
It's more safe, yeah. And literally every article that I've ever written on hail always refers it back to some sporting ball.
Yeah, it's difficult. When the Swiss ask people to report hail, they've got this excellent reporting apparatus. They've got an app where you can report it, and the way they ask is it grain, like a coffee bean, or the size of a coin of a certain value? What do they go up to? One of them's a tennis ball size, and anything larger than that is considered to be a joke report. Because you don't get very, very large hail over there.
Right, okay. But is it possible?
Yeah, I mean, it's possible, but it would be unlikely in that part of the world.
Tennis ball hail, it's pretty big. You wouldn't want that. Jumping back a moment to the uncertainty and the sort of the unknowns about the future of hail, what do we need to do to learn more and to be more confident about the future of hail, predicting hail? What kind of research areas are unaddressed?
There's a few. So one would be doing more modelling, more projections at these high resolutions that allow us to really see the storms. So that's something that I'm trying to do over cities in Australia, for example. But as we discussed, that's expensive computationally, so it takes a lot of time and compute expense to be able to do that. Trying to relate the large-scale conditions to where the hail forms in a more accurate way is something that I think is going to be really important. And as I was talking about before, it's an area where machine learning might be able to play a role. If we can have a better system that can take the large-scale environment and tell us more about whether hail is likely or not with less uncertainty, that would be extremely useful for things like looking at future projections or even for forecasting, where usually we're dealing with lower resolution data. And then understanding the processes that are involved. There are still physical processes that are not totally well understood, like the aerosol process that I mentioned. And I think especially with cities growing and more and more aerosols going into the atmosphere, we need to understand that kind of process and how these effects could actually change the microphysics inside storms and change the results for what happens on the ground.
Did you have a question, Sarah?
Maybe for the listener's benefit is when we're talking about aerosols, we're talking about like little particles of dust or other things in the atmosphere that are tiny, like little specks. You wouldn't even see them with the naked eye.
Like smoke or...
Yeah. Not a common misconception by any stretch, but what people may naturally think about is literally an aerosol can, whether it's what you spray your bugs with or dry shampoo or, any of those sorts of aerosols that we use in our everyday lives. It's like the same concept, right? Like it's same tiny little particles of something.
Yeah.
But we have aerosols up in our atmosphere. They can come from, smoke, pollution, dust, etc.
I didn't know that. I was thinking of, antiperspirant.
Yeah, right. So like we're all just up there spraying our antiperspirant. And that's what we do. Like when we're like cloud seeding or wanting to create hail, we're all leaning out the aircraft.
I'm thinking about preparing for a warmer climate and things like climate change adaptation and mitigation. Is there a lot of discussion or thought at policy level or industry level or government level about how to prepare for a future of different hail, or is it somewhat neglected? What's the lay of the land there, Tim?
There's a lot of thought, especially in the insurance industry, and full disclosure, I receive funding from QBE Insurance. There's a lot of thought in the insurance industry about understanding our risk. So that is about understanding where hail might occur, where it does occur, how that risk is going to change over the near and the long term. That I think is where the main focus is. And then there's this other aspect of how do we respond? Like, if we know that the hail risk is going up in Sydney, for example, what do we do? And for example, the current building standards don't have anything about hail. So hail is just not taken into account when you're considering what to build with in Australia.
Cheap, crabby roof tiles that I have.
Yep. Well, I mean, it's pretty rare that hail actually comes and smashes people's roof tiles, but it does happen.
It does happen. I just don't want it to happen. That's all.
Yeah. So that's where my mind goes first, is kind of what materials we could use to make things safer, what farmers could do by understanding better the risks to certain crop types or what they might be able to do to prevent hail from damaging crops. And then maybe thinking kind of more blue sky ideas. There's a question on how much the city itself might affect the kind of hail you get. So cities warm the environment around them. They produce aerosols through pollution. They have effects on the weather around them. And if we were able to understand the effect that a city might have on hail, for example, maybe in some far off distant future, we could build a city that was less hail prone. But I think first we need to understand it. And so right now I have an honest student who's working on this question to try to see whether there's an effect as kind of a first step into that kind of direction.
That's like, I wouldn't have ever have thought about how a city could interact with hail. Now that I am thinking about it, suddenly it makes sense with changes in airflow and heating.
Right, exactly.
And yeah, like this is really, again, like correct me if I'm wrong here, but it's really only something that we've been able to think about in the last few years as we're developing these ultra high resolution simulations.
Absolutely. And there's an awful lot of stuff that goes on in the real world that gets, we call it parameterized in the model. It gets simplified down into some basic interaction. You say, well, the city's warmer. Okay, you might.
Let's just say it's a few degrees warmer. Just smack a number on it, and
right. Or let's run the model and just pretend the city isn't really there.
Yeah.
Like,
yes.
This kind of thing. And I think now, especially through there's another group at UNSW led by Negan Nazarian, who's also in 21st Century Weather. And they're doing really excellent work on trying to understand urban effects. So she's helping me out with this project too.
But this is such a new development. Yeah, 5 years ago, it's not something you would have thought of in the global climate community, and likely not even in the regional climate community. It's just, you just didn't do it. It just wasn't thought of, in part because we didn't have the resources to do it. But one, we know better now. And two, we can actually start to simulate these ultra fine resolution or fine scale processes that there was no way that we could have ever done that before. So this is a really new development. I would even say like a few years ago, Zach and Iain, that I would have been like we can't do that. We're just not at that state yet. But that development's been quite, well, it seems to me anyway, it's been quite quick. Megan might say otherwise because I know she's been working in her field for a long time, trying to accurately model urban areas as much as we can. But until relatively recently, we haven't been able to have conversations about fitting them into larger scale simulations or simulations over larger areas.
Yeah.
Uncertainty in modelling is something that I want to touch on now as we get towards the end of the episode. But there's two other things that we haven't talked about, I think. And I'd like to ask Tim about, if you can answer this, I'm not sure if it's an appropriate question or not, but is warming in the upper atmosphere likely to have an influence on the future of hail?
I think the major effects, so it's surface heating that changes the instability, although I guess warming in the upper atmosphere would sort of cause everything to become a bit more stable as well. So it would have an effect. Yeah, I'm not sure. Are you thinking like stratosphere or?
Well, I mean, now that we're looking at the question in more depth, I don't know where this came from. It was at some point in my research for this episode that cropped up as something that could be a factor that influences how hail changes with climate change. But if it's not something that immediately you're like, oh yes, that's, here's the answer to that, then it might be that it was sort of a red herring.
Yeah, I mean, it's not something that I've thought about a lot. The most of the warming I tend to think about is near surface heating, near surface drying and changes in moisture, and then the changes in the melting, which also are not super upper atmosphere things. They're more sort of mid to lower atmosphere. But I believe that the whole atmosphere is warming, so there could be changes there as well.
And what about, we've spoken today, particularly focused on Australia, but also elsewhere in the world, about where hail happens most often. Will changes in storm patterns or shifting storm tracks have an influence on where we might see hail in the future?
Yeah, I think so. You can split future projections into kind of two types. One is the thermodynamic type, which is just what happens if the atmosphere is warmer. So that's really what I was talking about before with the changes to ingredients. Then there's the dynamic part, and that is how will the overall circulations in the atmosphere change? What will happen with El Nino and La Nina, and where will the jet stream be? And this just adds a whole bunch more uncertainty into the projections. So when I'm trying to work, I try to take an ensemble approach where we kind of look at various different models that could produce like a range of outcomes that you can then kind of try to look over and see what the uncertainty range might be. But the short answer is that yes, changes in circulations will have an effect, but they're very hard to pin down. They're harder to pin down than the kind of just thermal changes that I was talking about before.
Like you've mentioned a lot of stuff about hail that we don't know. In the next 10 years, what's the likelihood of some of those uncertainties being addressed or solved? And which ones would they be? Like where could we be in 10 years with our understanding on hail compared to how much development there's been in the last decade?
I think we're kind of at I don't want to use too grand a word, but a little bit of a renaissance in hail science. There was this big emphasis in the United States in like the 70s and in Europe.
Yeah.
And then it kind of went quiet for a while. And now we're at this stage where suddenly we're seeing these research centres being funded that are coming up and studying this stuff again.
Yeah, right.
So there's the Northern Hail Project in Canada. There's a big project in Switzerland, in Germany also. Here we've got 21st century weather. So we've got suddenly this momentum. And what I think could happen in the next 10 years, I sort of see it as expanding out from having an idea of what might happen at a single point, which is kind of what we had before. We had all these scattered points across the world where you might have an idea of what has happened there or what might happen in the future. But I think we're going to fill in the gaps, and we're going to have these kilometre scale models that suddenly are going to be able to tell us about things globally that we would not have dreamed of being able to see before. I think there'll still be uncertainties, of course. There always will be.
Yeah.
But
there's
I
always
think
more questions.
We're starting to get to the point where, even over the last few years in Australia, say, for example, we've gone from talking about changes in point locations or very generally talking about storms in general, not so much hail, to being able to talk about hail changes across the continent in sort of way, looking at maps that are much more filled in than before. I think that will just continue across the world.
Gosh, and even talking about a kilometre scale model that simulates stuff for the globe, like the entire globe. Like I still balk at that. Like 10, 15 years ago, like forget it. Like as if, like that's a nice dream, but that's where it's going to remain. And here we are. So there's, you know,
it's going to happen. I think it will happen sooner than
100%.
than we expect.
By the end of 21st century weather, it seems we'll have one here.
Probably.
So, and that's, you know, this is the scales that we're talking about now. So just those leaps of development are insane, and hopefully will continue and only get better.
Yeah, I hope so too.
Yeah.
That renaissance in hail studies sounds super cool.
Was that meant to be a reference or a joke? Or?
I mean, we're coming to the end of the session, and it's
really.
been
Can we keep talking though? I'm kind of enjoying this crash course in hail. Is that a bad joke? I didn't mean to do that.
Is there anything that we haven't asked or mentioned that you think people should know about hail, or something that you'd like to share that hasn't come up organically in the course of the chat?
I think we've had a really interesting discussion. I hope it's been useful for everyone who's out there. I think everyone's got a hail story, right? Everyone's got a storm story, and I always like hearing what people's are.
I've got many, but yeah, let's save that for a glass of wine or a beer sometime.
Sure.
I think.
So yeah, science-wise, I'm not really sure. I think we've done a good sort of coverage of the things that we should cover.
Yeah, for sure.
It's really interesting you saying about how insurance is really interested in hail. And like, yeah, from my experience, I would certainly agree with that. Like, yeah, they're so interested in things like hail because they do so much damage, whereas heat waves, they don't care. It's, a really one of their areas of active research, both in-house and, you know, supporting good researchers like yourself.
Yeah. Heat waves only hurts people, not expensive things, right?
Yes and no. They can hurt large scale infrastructure, but they're different. It's a very different impact. It's long term, more or less, with health and everything. But hail's like here now, intense. I won't say the F word, but I'm gonna F stuff up, and it can be very, very, very bad.
Well, I think we'll draw things to a close, and Sarah and I, along with everyone listening at home, would like to thank Tim for his time and fascinating information about hail. It's been really cool to learn about it, and I feel illuminated and ready to throw pellets of knowledge onto everyone's cars and windows.
Throw pellets or ice embryos?
That's what I mean, like little rocks of information
little
at
baby
people.
ones, little baby. Hope you've had fun too, Tim.
Yeah, I've had a great time. Thanks so much for having me on.
There was a lack of Simpsons references and time traveling today, so that's often our tangents.
I think I was too well rested and was concentrating too much. And
right.
Not enough caveats came up. It was too focused.
Usually I'm off on like about 10 or 15 tangents before we're 20 minutes in. That didn't happen today either.
It's been a very
I was on my best behaviour.
That's it for today, but there's heaps more on our radar.
We'll be looking at things like Arctic sea ice loss, sea level rise, and meeting the next generation of climate and weather researchers.
Join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.
Yay.
I don't even need to look at the script anymore to read that last bit.
That bit's always the same now.
Yep. I know it. I'll say in my sleep by the end of this season.